Algebra 2, welcome once again to this video on how to use the quadratic formula with the projectile motion scenario. So if you look back on the previous video in the section Q1, we were trying to determine, right, Mr. Arellano throws a basketball, gives the same information, initial height of 1.77, oops, I apologize, it should be meters, 1.77 meters, and a velocity of 6.85 meters per second. Well, on the other video, we were trying to determine when the object was at its highest point, and that required us to go from general to vertex form to tell us the maximum point, that the maximum height that the object reaches and how many seconds it would take. Well, this problem is a little bit different because it's trying to determine when the ball hits the ground, right? And as we've been learning about the quadratic formula tells us the roots of the equation. It tells us when it's going to hit the x-axis, and in this scenario, well, that'll be when an object hits the ground. So we're going to have to use this formula to go ahead and write when the object will hit the ground, right? A little bit different than the other problem because the other problem asks for when the maximum height was, right? So let's go ahead and write our equation. We always do negative 4.9 x squared. The negative 4.9 just comes from, this is gravity, right? Gravity is actually negative 9.8, but it's half of gravity when we do it with the quadratic equation. All right, and then again, our velocity goes here, so it's going to be 6.85x plus 1.77. Okay. All right, so now we want to find out when the object hits the ground. So to give you a quick little scenario here, right? Here I am right in this little section. Let's go ahead and draw me. I throw the basketball and it's going to go something like that. And I miss the basket. And it's going to bounce off the ground, right? Well, this little section here that we have, right, is a quadratic shape. It's like a U shape, right? And so we want to find the roots. Well, if you look here, this location here, we want to find when it hits the ground, right? In this scenario, this is when it hits the ground. So that's why we have to use the quadratic equation. And when we do it, right, if we continue, it also should give me a negative answer, but that's not going to make any sense, right? Because we can't have negative time. Right, we can't go backwards. So we're just looking for this positive root there. So let us go ahead and get started. All right, so I'll go ahead and we have the quadratic equation here. All right, if you wanted to, here is the video I was referring to, right? We want to find out, well, when and exactly how many seconds does it take for the basketball to hit the ground. All right, so let us go ahead and get started here. So I'll go ahead and write the equation one more time. We got y is equal to negative 4.9 x squared plus 6.85x plus 1.77. Okay, so let's plug it in. We're going to get x is equal to, we'll get negative. Okay, I'm just basically going to go ahead and write this whole expression here. All right. This is b squared minus 4, and I'm just putting parentheses, and I'll go ahead and fill in the information here in a second, right? So now that I have that, well, this is going to be my a. My a variable comes from the first term here. So a is negative 4.9, okay? B is equal to 6.85, and c is equal to 1.77, right? I'm just kind of following. The a comes from here, the b comes from here, and the c comes from here, right? So now that I have those labeled, so this part is negative b. So what's my b? Well, 6.85, so 6.85. Here I still have b squared, so 6.85. And then minus 4a, well, my a value was negative 4.9. And my c, well, this is c, so this is 1.77. Okay. All divided by 2a, well, 2a was negative 4.9. All right, now that we have this information here, let's go ahead and simplify this further. So now we're just going to get x is equal to negative 6.85, right, plus or minus the square root. And I'll go ahead and just do this whole entire section in my calculator because I definitely can't do that in my brain. And we're going to get parentheses. Let's go ahead and clear that. Parentheses, 6.85 squared minus 4 parenthesis a, which is negative 4.9, times parentheses again 1.77. Close it. Oops, I forgot the 7. Great, we go ahead and do that, and we get in here 81.61. So I'll just go ahead and write 81.61. This is all divided by, and if you calculate this, is going to be negative 9.8. Okay. Now that we have these here, let's go ahead. Well, let's simplify this here. All right, the square root of, the dot's not there. There it is. The square root of 81 is 9. So we should get something close to that, right? 81.61. Okay, close it. 9.03. All right, so we're going to get x is equal to negative 6.85 plus or minus 9.03, all divided by negative 9.8. Okay, now I'll go ahead and break this up as two equations, right? We're going to get x is equal to negative 6.85, right? I'm going to write the one that has a plus first, right? Negative 6.85 plus 9.03, all divided by negative 9.8, and we're going to get x is equal to negative 6.85. Now I'm going to do the minus, right? Negative 6.85 minus 9.03, all divided by negative 9.8. And as we proceed, all right, well, let's just go ahead and simplify this top part. So you can see I'm just doing all these step by step. We're going to get negative 6.85 plus 9.03. We get 2.18, and now we just divide it by negative 9.8. And that's negative 0.22. So negative 0.22. Okay. And over here, we go ahead and do this section over here, right? So let's go over here, and we're going to do negative 6.85 minus 9.03. We get negative 15.88, and now we just divide it by negative 9.8. 1.62. 1.62, okay? So, as we mentioned, so let's go ahead and just scroll up to the picture we drew over here, right? So we have this picture right over in this section here, right? So, I throw the ball in the air. Remember, this x represents time, all right? This is time elapsing, right? And so we notice, well, we got one that's negative, one that's positive. Well, this is one positive. This is the one that's negative, negative 0.22 seconds. And we get one that is positive, 1.62 seconds, right? So does this one here make sense? Well, let's go back to our diagram. It's probably referring to this root here, right? Well, that doesn't make sense in our problem because I'm throwing it right at this initial height here. And if this is time, this would be negative time, and that's just not possible, right? So this answer here doesn't make any sense. And we get this positive answer, and that one makes sense. So that means right here is 1.62, all right, seconds. This is how many seconds it took, 1.62 seconds, all right, for the object being in the air to reach all the way down here and hit the ground, right? So going back to our video, we could probably try to estimate it with our phone, but the ball is going to hit the ground at 1.2 seconds. So I can even just type that out here. You know, the ball will hit the ground at 1.62 seconds. There you go. And the answer is complete, right? Hopefully that helps you to solve this problem, and you're able to see how this problem is different than the other problem, which asks for the maximum height, right? The other one asks for this location here, the maximum height, which would require us to go from general to vertex. All right. Thank you very much.